Imagine the air as a giant sponge, sometimes heavy and wet, other times dry and eager to soak up water. When the air is dry, it pulls moisture from soil, plants, rivers, and lakes. This invisible force is called evaporative demand, a measure of how thirsty the atmosphere is. In India, where water is life, a thirsty atmosphere can spell trouble for everyone. High evaporative demand means water vanishes faster, even though we can't see it happening. The effects are real: wilting crops, shrinking lakes, and stressed forests. Climate change is making this invisible force even stronger. Many think only heat causes water to evaporate quickly, but it's more complex. Evaporative demand combines heat, humidity, wind, and sunshine. All these factors decide how much water the air can absorb. For India, with its monsoons and rivers, this atmospheric thirst is a major climate challenge. Our agriculture, economy, and daily life depend on a delicate water balance. As the world warms, the atmosphere grows thirstier, making water evaporate faster. We must understand, measure, and prepare for this challenge. The story of evaporative demand is about our future with water in a changing climate. Ignoring it puts our crops, cities, and forests at risk. Recognizing this force is the first step to adapting. It's not just a scientific concept, it's a reality shaping our lives. The more we know, the better we can respond. Our future depends on how we manage the atmosphere's growing thirst. Subscribe, like, and share Cosmo Academia. What makes the air so thirsty? It starts with temperature. Warmer air holds more water vapor, like a bigger bucket ready to be filled. On hot days, evaporation speeds up, which is why clothes dry faster in the sun. But temperature isn't the whole story. Humidity matters too. If the air is already full of moisture, it can't absorb much more. Dry air, on the other hand, pulls water aggressively from soil, plants, and reservoirs. That's why dry heat can be more dangerous for crops than humid heat. Wind is another key player. It sweeps away moist air near the ground, replacing it with drier air that's ready to soak up more water. Even on cooler days, strong winds can increase evaporative demand. Sunshine is the final ingredient, providing the energy needed for evaporation. On clear days, more solar energy reaches the ground, heating up soil and water, and boosting evaporation. Clouds block sunlight, reducing this effect. So a cloudy day can have lower evaporative demand than a sunny one, even if temperatures are similar. All these factors, heat, humidity, wind, and sunshine, work together to determine how quickly water leaves our environment. In India, these conditions can change rapidly, making water management a constant challenge. Understanding what makes the air dry helps us predict when and where water loss will be greatest. That's why monitoring all these elements is crucial for our future. A heat wave isn't the same as high evaporative demand. Heat waves are about temperature. Evaporative demand is about the air's thirst. This thirst comes from four main ingredients: high temperatures, low humidity, strong winds, and clear skies. When these combine, water loss from the environment accelerates. Take North India in May and June. Scorching heat, dry air, gusty winds, and blazing sun create extreme evaporative demand. Crops and water sources suffer even before the monsoon arrives. Contrast this with Mumbai during the monsoon. Hot, but humid and cloudy. Here, the air is saturated, so evaporative demand is low and clothes take forever to dry. The difference shows why temperature alone doesn't tell the whole story. A moderately warm, dry, and windy day can be worse for crops than a hotter, humid one. Focusing only on heat waves misses the bigger picture. The interplay of temperature, humidity, wind, and sunshine shapes the true stress on our water and food systems. Understanding this helps us protect crops, manage water, and prepare for climate impacts. It's about seeing the full picture, not just the thermometer. Only then can we respond effectively to the atmosphere's thirst. Our future resilience depends on it. High evaporative demand has real impacts across India. In 2016, Marathwada's water crisis wasn't just about poor rainfall. Relentless heat, dry air, and strong sun sucked moisture from soil and reservoirs, devastating agriculture. Even without drought, thirsty air can stress crops. In Punjab, wheat may get enough irrigation, but if the air is too dry, plants lose water faster than they can absorb it, stunting growth and reducing yields. This hidden cost affects food security. Water managers also struggle. Reservoirs like Bakra Dam lose more water to evaporation when demand is high, leaving less for irrigation, power, and drinking. Chennai's 2019 water crisis was worsened by high evaporative demand, which dried up reservoirs faster than expected. The atmosphere's thirst threatens both rural and urban India. It accelerates water loss, turning tough situations into crises. Farmers, engineers, and city planners all feel the impact. Managing water now means accounting for invisible losses to the sky. As climate change intensifies, these challenges will only grow. Recognizing evaporative demand is key to smarter water management. It's a silent force, but its effects are everywhere. Ignoring it puts our food and water security at risk. Subscribe, like, and share Cosmo Academia. High evaporative demand turns forests into tinderboxes, raising wildfire risks across India. When the air stays thirsty, it pulls moisture from leaves, twigs, and forest floors, drying out natural fuel. A single spark, lightning, or human activity can ignite massive fires in these conditions. Uttarakhand and Himachal Pradesh have seen more frequent, intense wildfires, linked to longer dry spells and higher evaporative demand. Before the monsoon, rising temperatures and dry air create perfect fire conditions. High evaporative demand acts like a giant hairdryer, stripping forests of their natural defenses. The result? More flammable ecosystems and bigger, more destructive fires. These fires release carbon, worsening climate change and creating a dangerous feedback loop. Monitoring evaporative demand helps forest departments predict high-risk periods and prepare. Early warnings and targeted action can save forests and communities. Tracking the air's thirst is essential for wildfire prevention. It's a proactive step in protecting India's forests from a growing threat. Scientists now warn of thirst waves, prolonged periods of extreme evaporative demand. Unlike heat waves, thirst waves are about the air's relentless hunger for water. They combine heat, low humidity, wind, and sunshine, putting intense stress on plants and ecosystems. During a thirst wave, plants close their pores to conserve water, but this halts growth and can lead to crop failure, even if there's some rain. India's pre-monsoon season is especially prone to thirst waves, which are becoming longer and more intense with climate change. Thirst waves can trigger flash droughts, where normal conditions turn to crisis in weeks. Recognizing thirst waves helps farmers, policymakers, and the public prepare and respond. Early warnings can prompt changes in irrigation, water use, and fire prevention. It's a new name for a growing danger we must learn to manage. Thirst waves shift our focus from just heat to the full spectrum of climate stress. Awareness is the first step to action. India must adapt to this new climate reality. Evaporative demand is rising as the planet warms. Warmer air can hold more moisture, making the atmosphere thirstier. For every degree Celsius increase, the air's capacity for water jumps by about 7%. This trend puts extra pressure on India's already stressed water resources. Reservoirs lose water faster, and crops need more irrigation to survive. Even monsoon rains are less effective, as more water evaporates before reaching rivers and aquifers. Farmers may need to switch to drought-resistant crops and efficient irrigation. Cities could face more frequent water shortages. Industries must adapt to tighter water supplies. Some regions, like Rajasthan, Gujarat, and the Deccan Plateau, are especially vulnerable. Detailed, region-specific assessments are needed to target adaptation efforts. The challenge is national, but the impacts are local. Building resilience starts with understanding where the risks are greatest. Subscribe, like, and share Cosmo Academia. To tackle evaporative demand, we need accurate data, but India faces a data drought. While temperature is well monitored, data on humidity, wind, and solar radiation is patchy, especially in rural areas. Many weather stations are urban, missing the realities of our farmlands. A denser, modern network of automatic weather stations is essential to track and forecast thirst waves effectively. India also needs more research focused on evaporative demand and its regional impacts. Current drought monitoring relies too much on rainfall, missing hidden crises caused by high atmospheric thirst. Investing in better data and research is vital for water and food security. Tracking evaporative demand is now a national priority. It shapes droughts, stresses crops, and drains water supplies. India must invest in a modern network of weather stations and make data accessible. Early warning systems can help farmers, water managers, and forest departments act before crises hit. Science must guide practical decisions to protect livelihoods and resources. Building resilience requires research, investment, and public awareness. The air's thirst is a new competitor for our water, one we must learn to manage. By watching the sky's thirst, we can secure a water-safe future for India. Subscribe, like, and share Cosmo Academia.